Alrighty, I guess we are all set, so we can go ahead and start this session. So I needed to double check actually my connections and everything because it's like today we don't have the class, so this is like a session that I set it up. It's not part of the class, of course, because we have like the winter, the storm. But I would like to talk about this. Um, really interesting project and a definition that I'm going to bring up to you. So it's just like a project actually done in one of the Scandinavian country. Yeah, it's Denmark, I guess, is Cirkelbroen Bridge. So as you can see that this project is working on the series of the interconnected circles, and then those are providing a kind of pathways all the way from one side of um, the island to the other side of the island, or like there is a canal actually, so it's bridging these two side of the canal, if you wish. So what we're gonna do in here, so we're going to work on a definition. It's simulating what you can see in this finalized version of that. Well, there are like I think I needed to flip these also to make sure that they are like the facing toward the outside. Anyway, so then we're gonna walk through the definition step by step. I'm not sure if we can finish it in one session, but I'll give it a try to see what we can do about this and then how much we can go forward. If you join us, please feel free and then ask your questions during the session into the chat in YouTube. Then we can go forward. So, all right. Okay, so let me start this with opening up a file. So I set up the like a kind of um, location. I mean, like the both sides of the shore and a boundary for the bridge. So these are both. I mean, like the three geometries in here. This one is a rectangle that I use a kind of unit less. I don't want to use any like a standard or metric system. So that's why just like later on you can uh, edit it, and then you can start a unit based sort of development, or after finishing it, so you can um, take it to any sort of unit that you would like and then rescale it again. So these two white boxes is supposed to provide the shores or the landing um, actually pieces, and then the rectangle, it shows the boundary for the bridge that we have. So let's just start with our definition in here. So what we're going to do, let me open up my Grasshopper. Um, it takes a little bit of time. I have like so many plugins, I guess, and that's why I need to spend a little time. All right. So now this is um, my Grasshopper canvas. So let me just like resize it because I have like few monitors around. Gonna make this in a way that we have like a kind of closer look of what we're having in here, but at the same time that you can have like better look on the um, definition on the right hand side. So what we're going to do in here, we're going to start a surface. You can have like the curve. From the curve you can make that surface, so meaning that you have like curve, and then this is the rectangle that we have, and then set as a curve. Then you can connect it to this as the surface. To make sure that you're not going to lose anything, so you can internalize this, and then this is going to get disconnected, so meaning that this is um, calling the rectangle from Rhino, and then this one has the surface of that curve internalized already, so you don't need to be worried about anything. So I'm going to divide the domain that I have. So I need to divide these domains to make sure that I'm going to have like the circles inside it. So let's say this is the bridge, then I'm going to have like the circles, and then with different sizes, then connect them together. And then of course that there are some of them that are going to be bigger, some of them that are smaller, so this is not a sector based definition. That's why I'm so interested in that. Sector based definition is always working with one sector of your work, and then you define this, then you copy paste it around, and in any sort of format that you have, like the sector of a pie, um, and a cake if you wish. But this definition is different, and the meaning that we need to work on the entire pieces at the same time. That's why I'm just like again, I'm more interested in that. So I divided this into 5 pieces. It can be 4, 5, 6, depends on what you would like to work on. And then the U count is going to be 5, and then the V count is going to be only 1. So meaning that I'm going to have only 5 pieces of the surface, like I'm using it as a kind of iso trim later on, and then 1 row of the surfaces. So if I look at this is the domain, and this is the U count, and this is V count. So then what I need to do is just like getting the iso trim to show me what's going on within this surface that I have. So this is a domain, and this is my surface. So now if I go and then turn off this and control the space bar, turn off this, now I can see that we have like 1, 2, 3, 4, 5 pieces. And let me just lock this later on. We're not going to, just like touch this again and again. The shore boxes. So 5 pieces. If I would like to change it, I can make it less or more. Like starting with 5, you can make it 4 or 5. Then later, I would like to see populate the 2D geometry. So I'm going to populate 2D points like the on a surface. So if you go under vector and then under grid, you can see they populate 2D. So meaning that it's populating the points, the random base, the different seeds on a 2D surface. So what you can do, you can connect these 5 surfaces to the region. So meaning that it's being treated, each of these surfaces treated as the separate surface. You're going to have like the 100 points on each surface, or the isotrim of the surface. So I don't need that many, so I'm going to start just like making probably like smaller number. So the 5 would be nice, but as you can see, because the seeds, the seeds for the random distribution is the same that we're using, that it's 1. And then if we're going to change, that doesn't matter. So we're going to get the same seed again for all of them. the location of the points, as you can see, for the cell 1, 2, 3 through 5, and any other number that we have. So it's going to be the same. Then what you need to do is just like you need to make sure that we're going to get like a random distribution, and a random distribution of the seeds this time, not the only the points. So the random distribution of the numbers for the seed is going to end up with the random distribution of the points on these surfaces. So what you can do, you can get like a random number between like 1 to 100 or 1000 if you wish. And this is the domain that I use for this. And that's the range that I have. It's a domain. And I'm going to use the how many numbers that I want as a random. So because I have like 5 cells, I need 5 random numbers. So I'm going to use the number of the U count for the number of the random distribution that I want. And then I'm not going to touch the seed for the random number. So I'm going to use this also for the seed. But also you can use the round to round the number, just as a kind of practice. So you round this number to the nearest or floor or ceiling. So the lower part, the lower number, and the upper number. I'm going to use the nearest actually for the seeds in here. As you can see, now we have like the random distribution of these points for each of these, and then they're different. So meaning that, again, one more time, so this is like the random distribution for one of them, which is like a copy of other 5, and then now we have the random number for each seed or each cell that we have like 5 of them in here. So, and then of course that we can get the a list item to list item under, let me go under the sets, and then under the list, and then you get the list item. And for the list item, I would like to get something like all of them. That's fine, just like 0. So meaning that I have 1 point in here, 1 in here, 1 in here. So I'm picking the first index of each of these 3 branches in here. So and then only index 0. And the rest, I don't need them. If you would like, you can change that, but just like it's already random numbers and already random distribution of the points. So now you can see I don't need to make the different sizes for these cells, because the location of these points are not just like the same location as the juxtaposed cells. And then I can also use these as the 5 center point for the circle that I would like to draw in here. Center point for the circle. So these are the items, and then I need to just like flatten this to make sure that I'm gonna get every one of these members actually on one branch of data. Then use this as a plane, and then for the radius, again, we need to have like the random number. So because I have like the unit in here as a kind of unit less, so as you can see from here to here is 10, meaning that the entire bridge is like something like 30. I would say probably it's close to a meter, like 30 meter from the beginning to the end. That's why my circles are going to have a random radius between like something between like 1 meter, which is going to be 2, the diameter is going to be 2 meters, to 8 at most. We can change this later on. Sorry. So we can change this later on if you want, but for now it's okay, I guess. 1 to 8. So this allows us actually to have like the all the random number between 1 and 8 associated with the radius that we want. We are going to use the same number because we have like the same number of the circles, so the same number of the randoms. And then C's, now you can say that, for example, some number like 27 in this case. So I'm using the same number that I used it for the definition that I showed you, just to make sure you're following the same for the certain shape, but we can, just like change it later. So now we have like 5 circles, 1, 2, 3, 4, 5, and then they are overlapping not only each other, also they're overlapping part of the canal's connection, and then the dirt. So this is sitting in the right location based on what we need. So from here, we can go forward, and then we can make these all as one single geometry. And then to do so, we go on the intersect tab, and then you go on the region union, and then connect all of them together and make one geometry altogether. That's really good. I think this is, you can see, is a green, so all of them, they're connected. And then if you would like, you can extrude this, just to give you the shape of the geometry that we have. So it's going to be along Z, and it can be going up or down, doesn't matter. So I'm going to use I don't know, also negative number. So this is negative number, and if this is 1 unit, so I'm going to go with like 0.3 units, meaning that 30 centimeter as a kind of, just like a thickness of this, if you wish, just like it can be any other numbers too. Anyway, so also I'm going to cap this, and to make this geometry completed. So turn them off, and then also turn these guys off. Now I can hide this because I don't need it, and also I can turn off this geometry too. So now I have like the bed for my bridge, connecting one side to the other side of the canal, and then that is the base for what we have done in here. So if we would like to go to the next level, and then we would like to add the handrails in here. So what we can do is we can start a kind of, just like extracting the boundary of this geometry to use it for the handrail. Just like a step by step, let's go forward. So I'm going to offset this, and then offsetting it, so it's going to go to the outside of this geometry. So let's offset this. So by default is 1. I'm going to use again 0.3, but this time instead of 0.3 positive, and it's going to be negative 0.3. No, sorry. I need a let's say between -1 and -1 and 0, and I need to have like the probably 1 digit would be good. So we have like minus 0.3, so we're -0.3, and then we have the distance. Now it's sitting inside. So yeah, 0.3 is good. Okay, so -0.3, and then later on we can come back and then starting, just like adding some location for our handrails. Or we can do it now too, so that's fine. I guess it would be um, good. Okay, I think it's good. So let's move on to work on the points on this curve. I divide this uh, by number of the points that I would like to say, probably. Oh, it's too many. Perhaps 300. It's a little bit, just like too far away. So probably 400 would be good. Okay, so we're using 400 points just to build up that handrail, the shape of that. So just to make sure that these are getting connected well, I'm using like the interpolate curves. So using all these points and then connect them, and because it's open at some point, then I need to close this and make it periodic. To make it periodic, so because this is open, it's false, meaning that it's open. So I'm going to invert it to make it periodic, and then it's going to be a closed curve. So we move this up to make the upper um, curve of the uh, handrails. And how much? I guess something like, and this is along z-axis, of course. And then how much we're gonna move that? It's going to be moved like 1 point. Let me see what I have the numbers. 1.2, and that would be our ending point for the handrails in here. Again, offset it, because as you see, probably in here in the um, original image and design of that. So perhaps that what you can see, that there is a sort of, just like like this slope in here. So it's like the deviation from 90-degree angle, so it's going inside, you can see in here. So what we would like to do, just like offsetting this to the inside, and -1 to 0, and we're going to get more inside. Then we can turn off this geometry, and then we can turn off the move. So all we need just the points and then upper handrail in here. So, and then we need to move the points also, and then reflect the points on that curve. What we can do, we can pull the points. This is the curve, the geometry, and then these are all the points that we got from the divide. So these are getting to pull on that curve that we have on the top, like the handrail top part. So all we need is just like using the line from 2 point, starting with the point that we got in here on the curve. So this is the start point, and then end point is the closest point that we got on the upper side of the handrail. So now we got them connected, so everything looks good. And then I can turn off, and then I can turn on this one, because this is like the handrail. So just to make sure that our handrail also, it has like the thickness to that. So I use a pipe, and I'm going to pipe this, and then give it a number, like probably um, something between 0 and 1 would be good. That radius cannot be 0, so not zero point 0.3. So sorry. So this is going to be too much, actually. Let's go back to something like 0.0 4 or 5 or something like that. So let me make this 2 digit. We don't need 3 digit actually. So 2 digit, okay. And point 4 or point 0.3 would be interesting, I guess. It's a good size for that. So as you can see in here now, we have set up the circles, and then the handrails for the bed of the bridge. Now I'm gonna get back to the starting part of the definition. So I would like to and make this a little bit, just like playing with the numbers. So, for example, if I change this and then random numbers from 27, because we use 27 to make sure that everything is going to get connected. But if I go start working with this, so there are other options also still we can find, as the all those 5 circles, they are connected, and then they're covering from one side to the other side. So let's like this, like 79. We saw a couple more like this one. Oh, 88 is beautiful. Like this one too. So you can, 19 is nice, is beautiful also. 19 wasn't 19, no, 23, sorry. 23 is really nice, is beautiful connection. And it's the choice of the that one. What was the other one? 10, number 10. So those are the choice of the designer and architect. So you can grab whichever you want. Of course, that we can start manipulating the definition, and then make it a little bit, just like more advanced, to make sure every one of these iteration that they're going to get connected. Otherwise, just like they're going to be called out, and then we're not going to use them. So, but for now, we're just like relying on your taste and then your choice for the definition that you want, rather than just like writing the entire definition in a way that always giving you like 5 circles or part of the circles, and then they're connected to both sides of the canal and here. So, and let's go to the next part. Let me see my definition for like a quick recap of what we can do and what we need to do actually in here. So, um, just give me 1 second, because I have like these guys. Mhm. All right. So the next part is going to be the poles. If you remember, there are the poles and then the structure, and you can see in here. So we would like to build these poles, and then partially is go underneath it. So I'm not going to make on the detail of this part, like the, because basically this definition is focusing on the strategies rather than making the exact same thing. Although that there are some details that you can um, discover more about later on. So what we're going to do, just like using those 5 circles again one more time. So let's find this. Um, before we go forward, let me do something. I would like to say that these are This is our bridge bed. So this is our bridge bed. So this is our, let me delete this. This is like the part of the definition that we have for the handrails, just to make sure that we have like everything set up. All right. So this is the first part with the distribution of the points and everything. So all right, and now we're going to have like the circles again one more time from these points. So these are the location for those points that we use them for the center of our circle. So again, one more time, we need those, and then we need to make like the circles for the poles. So I use like something between 0 and 1, and I'm gonna use it like 0.3. So this is gonna be the radius of the poles, and the poles is going um, to be going down um, to um, make the connection to the bed of the river or canal. And to do that, I extrude this as a kind of, just like sort of number, like a Z, along Z, the direction is going to be along Z axis, and negative because it's going down, and I'm not adding negative numbers. So sometimes I add negative numbers, sometimes I put the negative, I'd say, um, component, and because I would like you to see different sort of strategies that one. All right, so we have to connect these, and then now we got the poles is going all the way down. Again, if you would like to work on more details, so you're free to explore more. But in here, just we're making some um, specific sort of definition for the strategizing the design of this project. All right. So let's move also one more time these circles because we would like to build the poles going up. So we move them to the, um, let's say along Z, of course, it's going to go up. And how much? I'm going to make something a little bit, just like probably more interesting because the thing is we have like we can add some numbers, but I would like to make this dependent on the circle of these, I mean the radii of these circles, meaning that if we have like the larger circle, then the pole is going to go upper and it's going to be taller, and then we have like a smaller circles, then the poles are going to be shorter. So the larger the higher, and then the smaller the shorter. So what we're going to do in here, so we have like there are different things that we can do. So one thing is I would like to use a multiplication components to use the number that I got for my circle radii, and I'm multiplying that by a number, let's say something like 2.2, and just to make sure that it's not going to be the multiplication, it's going to affect too much of the of the height of the pole. Then I would like to add a variable to make sure that this is a only addition that is controlling point for the height of these poles. So then I'm going to add like probably something between 1 and 10. They use 8.5, and now we have like sorry 8.5 added to the addition in here. Then the entire thing is going to go up. Now the location for the top side of the top point of the post is appearing. But the thing is, now we have like a cylinder, but the as you've seen in the project, that the shape is tapered and the pole going up is getting tapered. So what we're gonna do, you're gonna taper those geometries, taper those poles also to make sure that we have like the going up like a kind of a smaller circles. What we're going to do, we're going to scale, and scaling what? Scaling those circles on the top with the center of those circles, and then the factor going to be half, 0.5. So now we can say that we loft the geometries from the top with the bottom one. However, we're going to have like some issues as for the connections. That's why we need to graft our data set. So because they're all of them, they're in one branch of data. If we connect those, they're going to get connected to each other. We don't want them. We need to match the data set with the data set that we get from the circle on the top. So we need to put each of these circles in a separate branch. So to do so, because I don't want to graft it in here, I use the graph component to make sure that the graph is happening separate from that, and then another graph component for this. Now, if you look at the data, so you can see that each of these circles being listed under separate branches of data. So now we can use them, and then we can connect those, and just to make sure that, because we have like different branches of data, so we have like on branch probably 2, yes, a branch 2 and a branch 3. So all we need to do, just we can simplify the data, or the graphed data that we have. Now they're getting connected. Beautiful. Oh, it's perfect. Okay, so we're almost getting the structure for this interesting project done, and then all we need just like to add the cables, and then cables is going to be connecting and then keeping up the entire the structure. So that is going to be a little bit more, I'd say, advanced stuff, because we need to make sure that we have like all the things connected properly with the cables. To do so, what we're going to do, like, let me double check one more time my definition again. So okay. Um, as you can see that there is another ring, and then you can see that the distance between the ring is dependent on the radii and the radius of the circle. It's corresponding with that. So there are different heights. Then we need to make sure that we're getting a kind of, just like relative type of height in here. So what we can do, we can first of all, we can move um, those circles a little bit downward. But if we're going to do that, so everything would be the same level. So what I would like to do, I would like to um, let me just taking care of like too many windows in here. Okay, so I have like moving these guys and moving them like along Z, just a little bit downward because it's not sitting, this first circle is not sitting on the top as you've seen this in here. So it's a little bit lower than the top side of the top part of the poles. So move them down just to make sure that I'm going to get the upper ring on the top. So then it's going to be negative, and a negative like let's say 0.5, then moving it down. So this is building this ring that we have in here, the upper ring. Also later on we can add like some detail like piping it, but for now it's okay, I guess. So the next part is getting the bigger ring, which is like lower than this. So moving like the same geometry. I'm gonna tell you why the same geometry. These are like smaller, but we need to make sure that those smaller ring can be projected on the cone that is covering the shape of these cones that we have in here. So this is a cone. It's building upon these bases. So then if we have like the circle going down to this level, then we project it in this cone, then we're going to get this circle. And then this ring, actually the lower ring. So let's build that, and then we need to do more later. But let's build that at the Z axis and a Z unit. So how much? I'm going to use the same number that I had for the circle radii in here, and connect it to a, let's say, uh, multiplication component, and at this time going negative, and this time I use 1.2 times of the circle radii to have like these larger rings at different levels. So meaning that if I look at the data that I have, so these are at different levels and dependent on the size of the circle and then the radii of the circle that we got. in here. So let's move on to the next part. Uh, Next part is our work um, to let me see this. This is going to be really um, to make the cone first. Yeah, the cone first. Um, that is going to be the circles uh, from the lower side. So these are the circles. Sorry, these are the circles from the bed. I use this to loft it because I would like to loft it that they are on the same branch. So I graph this all these circles. So I'm gonna have like 5 circles and 5 different branches. Then also I have like the circles, the top circles, and those rings also can be grafted in here. And now I can loft both to make that cone shaping our structure, and then the cables coming down it's sitting on that cone. So what else we need to do, we have like the lower rings, so we need to make these lower rings. To do so, we have the project of the geometry on the birep. So we have like the curves, and then these are our curves, and then this is our birep, meaning that we have our birep in here. And then now we can see that one other thing that we need to do, just like we need to make sure that these are also drafted, because these are all on the same branch, but the loft are different branches, so they should be matching with each other. And then of course that if we have like the let me see um, the direction, because now it's projected to the top. The direction is Z. Now we would like to have the direction instead of Z. Um, we can have like the X or Y, but let me, instead of using project, let me use pull. The curves would be easier because it's going to pull all these curves that we have to the surface of these geometries. Okay, now it would be interesting. Okay, so now we got these ready. I'm going to turn off this. Also turn off these guys too, and this is good. Should we start merging these things, because later on we have like all those part of the definition around, then finding those gonna be a kind of problems later on. So I put all of these together and building the bridge step by step. So, and then now these are all together, I guess. Yes. So turn them off for now. All right. This is the ring, the second, the lower ring. All I need, like piping, I guess. I can pipe it, and I can pipe that with like something probably point 0, point 0.5, 6 probably. That would be nice. Yep. Um, Unlock these two. Okay. So one, and then also um, we had the circles at the top. Let me find the circles on the top. We need to pipe that one too. So these are circles are gonna go up. This is like that, and then okay. So I guess we have it somewhere in here, and then moving it up, and then scale it, and moving it down. There you go. So this is moved down, scale, and I'm going to pipe these two. Uh, and then this is going to get piped, and um, yeah, I guess we are all set on this part. Uh, so the rest of the pipes of the definition. So this one, and then pipe this one. So these are all pipe. Okay, cool. So let's move to the next part. To the next part. Um, um, we have like the um, um, cables, and then we would like to set up the cables. But the cables, because we have like so many points, we don't want to have like this many cables. Starting from like the bed of the bridge. What we need to do is just like dividing that curve uh, with probably uh, uh, the smaller number. So what I'm gonna do, I'm gonna use these. This is all those circles together, and make a curve. Contain it in here. Use it in here, and now instead of 400, going to divide this by points with 100 instead, meaning that I have like less cable, fewer cable than the number of the handrails that we have in here. So this is 400, and these are the cables like 100. So you can make it less or more if you wish later on. Let's go to the next part because we need to make sure that our curves and then points are going to be properly actually located. So to do so, we need to get a point in curve component. So point in curve, and then this is going to give us like the points, and then this is the curve, and then we can see that they are uh, some points that they are, because this is like one curve altogether, the 5 circles, so we need to make a separation between those. So this way, that if we have like 5 curves and 5 times we compare the points against this, we're gonna have like 5 different branches. Right now we have only one branch, but we don't want one branch, we want 5 branches, 5 times of um, um, comparing all points against um, the circles that we have in here. So and then that way we can say that, for example, sorry, we can say that the curve. Um, um, well, oh, sorry, I got it from like the region union. No, I needed to get it from circle. Why I got it from curve. I have like 5 circles in here. Yes, 5 circles, and then this is again. I'm gonna region union in here um, altogether 5. But this time, instead of these guys, I'm gonna use it. This is going to be connected to this, and then this is my circle. These are my circles. Use these as 5 different branches. So now I have 5 different branches. All those points have been um, comparing against each circle. So now I can see that I have like the points on each of these circles. So these are corresponding with these circles rather than the other one. So we need to make a separation between these 5. So now easily we can call out the points that we don't want. Those are the points that it's distributing on the bed, and then we don't want them because we want only cables going from the perimeter of the bridge rather than on the bed, so it's not being used that way. So um, this is going to be the relationship. It's 0 and 1, so it's the call pattern, and then these are going to be the points. Now we have all the points in separate branches belonging to each circle, corresponding with the upper circle, so we can connect them later. So all we need to do, just like finding, this is a really, really um, um, hard work you need. So what we need to do is just like, first of all, so we need to um, simplify this because this is like 5 different, I mean, like, yeah, 4 times. So simplify this. I'm going to pull the points from um, the points that I have in here to the um, circles that I had at the top. So this is one, and this is going to be simplified again because I guess, oh yeah. So the 4 branches, so simplify this one. So to make sure that they're sitting on the root. And then now I'm connecting this. Oh, that is nice. Beautiful, because now we have like corresponding points from the bed with this circle on the top. Okay, so this is number one. Although that we didn't need this, to be honest with you. So the projection of the circles from down to the cone, to the top of the cone. So we could have used just the circle easily rather than those. But that's fine, I guess, because we have like everything in here grafted already. So I use that grafted data to make sure that they are connected properly. So the second part is our pulling the point again. This time, of course, the same database that we have in here from the call points. We have like 5 branches of data. And then the geometry coming from like the pool of the curves. So all I need by this also, then connect them to the geometry in here. So now we have like a really beautiful corresponding like a points in here, three of them in here, and then 3 of them on the top. 1, 2, 3, 1, 2, 3, and then we have 1, 2, 3. So that is really nice. The other ones also, they're corresponding with each other. So we're almost done with our definition. It's a little bit, just like more, but we're getting there. Just to finish this, we need to connect these points. First series, the second series, and then also third one. So 1, 2, and then 3. So 1, 2, or if you put it into order, so it's going to be 1, 2. 1, 2, and then 3. All right. Okay, so let's just start with 1 and 2 first. And line. So start point, and then closest point, the end point. Nice, perfect. So they're all connected. And then also we need to have like one more lines, and then 2 point. So this is in this one, and then this is going to be the start point. This is going to be end point if you wish, or the other way. Beautiful, nice. Just to wrap up this definition, so we have like all ready in here, just connecting these lines too, and then all we need to do is just like turning off the rest of the definition, and then turning on just that merge. Nice, perfect, beautiful. So it's done. And then of course that you can work with let's see, because it's not going to be, of course it's not going to be perfect with each like scenario that we have, like the different circles and everything. But let's see, for example, we talked about like number 19, I guess. Let me see if it's going to work. 19, those are separate. I think it was 23, something like that. Yes, look at this. So this is 23, and it works perfectly. So now we have like 5 circles, And then we have like other geometry. Oh yeah, this one for example. This one. Oh, it works really nice. So we have like five circles again, and then connecting. So it's fully parametric. It works with the um, different situation. If you wish, also, oops, um, also you can um, bake this. Now let's get to baking part. So and baking this all together, and then as a group, and then under layer 5, then I'm going to turn off this, and now I can take this also and make it Arctic. So this is beautifully done. All right. I guess we're all done in here. Um, um, if you're watching like right now or later on, so you can let me know if you have any sort of question. And hope you learn this tutorial and hope you enjoy it.